Hello friends, here we have integral with roots, and to solve this integral we will use trigonometric substitution. So to use trigonometric substitution we need a right angle triangle. Okay, let's draw it. So we need a right angle triangle with angle theta. And why do we have to use trigonometric substitution here? Because in our denominator we have a root, and this root x squared minus 1, this formula resembles Pythagorean formula. Okay, so and since we have here minus sign, then this formula will be one of the sides of this trigonometric right angle triangle. Okay, let's say that our formula, this formula is a formula of opposite side of a triangle. So square root of x square minus 1 square. Okay, in that case, our hypotenuse will be x, since we have here x square, and 1 is subtracted from x. That's why it is also hypotenuse, and adjacent side will be 1. Okay, now we will use one of the trigonometric functions. It must be sine, secant, or tangent. Like here, we will use secant. Secant theta equals to, okay, what is secant? Secant is hypotenuse divided by adjacent side. So it's a reciprocal of cosine. That's why it will be x over 1, or it's just x, right? X over 1. So our x equals to secant of theta. Now we can substitute secant of theta for x's here. And what is our dx? So to define dx, we have to differentiate this x equals to secant of theta, this equation. So that will be derivative of x is dx, and derivative of secant of theta with respect of theta will be secant theta times tangent theta d theta. Okay, and then now we are ready to substitute. Then our integral will be integral, what is our dx? Numerator is secant theta tangent theta d theta. Okay, then denominator x square. What is our x? Our x is secant theta. Then it will be secant square of theta. Secant theta squared. And square root of secant squared of theta minus 1. Okay, and here you can see we can cancel this secant and one of this secant of the secant square. Then what will we have? We will have integral. Numerator is just tangent of theta, d theta, and denominator will be secant of theta times square root of, now secant square of theta minus 1, it is another Pythagorean identity, right? So we have tangent square of theta plus 1 equals secant square of theta. Then secant square of theta minus 1 will be secant square of theta minus 1 will be just tangent square of theta. Okay, then that will be tangent square of theta. And again, you can see here square root and square cancels, right? And we're left here in the denominator just tangent of theta. So in numerator tangent of theta, so they also cancel each other. So what do we have next? Our integral will look like 1 over secant of theta d theta. And since secant is a reciprocal of cosine, and 1 over cosine, so that will be integral of sine of theta. Oh, sorry, cosine of theta. Cosine of theta d theta equals to, and now we have to just integrate cosine, and integral of cosine is just a sine plus c. Okay, but this is not our final answer. Our final answer must be in x term. So to find the x term of sine of theta, we will again use our trigonometric, this right angled triangle. Okay, then that will be, so what is sine here in our triangle? Sine is opposite side over hypotenuse. Opposite side over hypotenuse. Opposite side is square root of x square minus 1 square, which is 1. And then opposite or hypotenuse is just x plus c. Okay, this is our final answer, the solution of this integral.